Hello, hi, Assalamualaikum and salam sejahtera. Good day, everybody. Welcome back. Today's topic we're going to discuss on strain gauge. It's one of the transducer equipment. All right. So let's get on with it. Okay. Before we begin with the equipment, strain gauge? Let's talk about what is actually strain means. Okay, basically strain is basically the amount of deformation of a body. A body can be anything, a metal or any equipment, anything. When force is applied, a torque or pressure, a displacement or acceleration. Okay, so it's a measure of how much force is applied to a certain body. Okay, let's take a look at this figure here. They say this is let's say a metal or something like that. And when you apply a force either this way or maybe that way, this metal will experience some sort of elongation. Let's say the initial length is this one, it's L, and when you apply a force sideways, then it will produce some little change of length due to that force. Okay, so strain is calculated as a fractional change in length over original length, which is you can calculate it using this formula here. That strain is basically a dimensionless item. It's delta L divided by the original length of that body. Okay. Where, delta L is change in length in meter. It can be millimeter, micrometer, centimeter. Okay. And the initial length is L. Okay, there are two types of strain. The first is if we measure that the strain is greater than 0, which is called, this we call a tensile strain. A tensile means means like a pulling kind of strain. Okay, so it's the force of this body, this is the force is going sideways to the right and to the left. Another type of strain, okay, is basically we call it a compressive strain. Okay, the compressive strain is basically when your force is going inside and try to push the metal or the object to compress or to become shorter in length. So it's a positive strain, means the tensile is trying to increase the length. If it's a compressive strain, it's a negative value, it's trying to push and reduce the length of the object. Okay, so although this strain is dimensionless, strain is sometimes expressed in units such as inch over inch or millimeter over millimeter. As I said, it can be a meter, it can be an inch, depending on where you are. If you are in the US, maybe you prefer to use inches. If you are in the other part other than the US, then preferably use in the SI metric system, which is meter. Okay, so in practice, the magnitude of measured strain is very, very small. Imagine a metal, as the object is the object is the metal. Then, if you put a force, then it will not change length in a very drastic like a rubber band. But okay, so basically, depending on the type of material or object that you're going to put a strain, then it's for example, most application is used on a very solid metal, so often expressed in microstrain and is measurable using a certain transducer. Talk about that after this. So if we can calculate this, why we need to measure using a transducer? The answer is the strain basically in actual practical application. The strain can be applied and it's changing from time to time. It depends. For example, if you put a metal outside at a very hot temperature, the metal will expand like a bridge. Expand. So this kind of expansion and compression is changing every day, and we need to engineering have created devices in order to improve, to make the measurement of strain much easier and can be done automatically. Okay, this is where the instrument transducer strain gauge comes into play. Okay, so you have what you call a strain gauge. Okay, it's basically an electrical and a passive transducer. Okay, so passive transducer means you need a power supply in order to produce an output, which it sends and transform the deformation of an object due to amount of strain into proportional electrical resistance. Okay. So how this device looks like? It looks like this. Okay, like this. So basically you have, there are basically two types of strain gauges. We'll talk about this later on, three types. So basically this is a function. So basically the strain gauge, basically there's a lot of wire, a curved wire, very long wire, not very long. But if you basically put a strain, a force into this, basically you put a force, like a tensile force, and then the resistance measured between these two terminals will change. Okay, will change to a certain value. So the change in resistance of the strain gauge is a reasonable linear function of its deformation. We're saying that the more tensile strength or the more force you put in that strain gauge, the higher or the lower resistance will be. We may talk about that after this. Okay, so how is it used? The strain gauge basically is attached to the object by a suitable adhesive. Okay, you have like a tape. It's very small, like this size maybe. Okay, and you put into a suitable adhesive. You attach it to, for example, let's say assume this is a metal. You attach it like a cellophane tape on top or at the bottom. Okay, using a very strong cement glue. And then as the object deformed, the strain gauges will also deform. Okay. Also, if we attach it like this, very thin, and it will follow the deformation of the object. Okay, if you put this way. Okay, so causing the electrical resistance to change. So the value of this resistance of its resistance, basically it's R here, is proportional to the amount of strain the object is put into. Okay, the higher the strain is increased, the greater the resistance. So the level of strain can be measured. Okay. Just talk about a few type of strain gauges. It can be classified into two types. Basically, a metallic type can be also classified based on either using wire or using a foil. And the second one is a semiconductor strain gauge. Okay. So let's talk basically about these two strain gauge. Wire strain gauge. So basically, the wire strain gauge is an early type. Normally, when the engineers start to design and build a commercially available strain gauge. They put some kind of a wire, like a wire, very thin wire, as a strain gauge. So it's made of a very fine wire, less than 25 micrometers, very fine and very small, and it's looped back and forth. So it's looped back and forth on the base of the mounting plate. This is the mounting plate. Okay, it's attached and glued to a mounting plate, or we call it sometimes called a carrier. The wire is insulated with thin insulation to avoid damage, of course, because this thing will be put in an object, maybe outside, it may be harsh environment. Yeah? Okay, so to prevent it damage the wire can be corroded or can be scratched and so on. And the wire is spread evenly to sense uniform distribution. Okay, basically the length and the space between the loop are all equidistant and are evenly distributed. Okay, so and then the wire is bonded to a carrier on a thin sheet of paper of Teflon. So on top of the carrier, there's a Teflon paper to protect the wire, and the Teflon is bonded to an object we want to measure. Basically, it's glued or cemented to the object. Okay, a foil strain gauge basically looks like a wire gauge. It's the same. Okay, except instead of using a wire, it uses a foil up here. This is a foil. It's a bit thicker than the wire. Okay, it's widely preferred. Okay, than wire gauge. Foil strain gauge has the same characteristic. Okay, basically the way it is used. The only difference is basically the type of conductor used. It's wire, and this is a foil. Okay, so foil gauges are preferred since they can be manufactured in shorter gauge lengths than wire gauge and have less sensitivity to transverse strain. Okay. So it has also a flatter construction which makes them less susceptible to damage. You know, if you have a wire, then it may be a little bit bulgy a little bit, and it can easily be scratched. So if you have a foil, it's a flat surface, then it's less susceptible to damage and allow them to conform to curved surface more easily than a wire. Okay, so this is how it looks like. I just managed to get this picture from the Google, and so this is basically, okay, so there's a wire, very thin line, loop back and forth, but if you look at the foil strain gauge, that's much thicker, but it has some advantages over wire strain gauge. So another type of strain gauge is called a semiconductor strain gauge. This is a bit different. It has a very high gauge factor. We'll talk about gauge factor later on. and then it used resisting material used to make this gauge is a semiconductor type, for example, germanium and silicon. So you have the same base, the same carrier here, but the only difference is you have a semiconductor element in between inside this carrier. Okay, so this is how it looks like in real, in optical. So the advantage of semiconductor strain gauge is it's smaller, higher sensitivity, low hysteresis, and it's more elastic and has a longer lifetime. But of course, there are also some disadvantages. Although it's a very high gauge factor, it's very sensitive to change in temperature. For example, if you put a semiconductor in this temperature environment change drastically, and then the measurement resistor will also change. Okay, so it might not measure the strain very accurately. It's very more expensive, of course. It's the same thing, more expensive, and it's non-linear resistance to strain relationship. It can have a non-linear. It's not totally 100% linear. Okay. All right. These limitations can be overcome through software composition, of course, but it will cost you more to buy a semiconductor strain gauge. So okay, we'll stop now, and we'll move on to the next video on how a metallic. We're not going to focus on semiconductor gauge. We're going to focus on the working principle of metallic strain gauge, which is of foil type or a wire type. Okay. So let's stop now. I'll see you in the next video. So see you again. Thank you very much. Have a nice day.